Hello friends, in this video we are going to do the tree traversal algorithms using stacks. This is the example of the pre-order traversal. In pre-order traversal we have the process of scanning the nodes of a tree in a manner of root, left and right. So first of all, whenever we traverse this tree in a pre-order, then first of all we have to scan or process the root node, then the left node and then the right node. First of all, this is an example where we are using this figure. Here A is the root node and this is the left subtree and this is the right subtree. Now the sequence in which we will first scan this tree is that here we have basically will take three lists. First is the nodes in which will be processed, then the pointer where the pointer will point at a particular time, and the stack where we will push up the different nodes. In the first case, when we start processing, the pointer will be at the root node. So pointer is at root node A and we have 5 in a stack. It means that there is nothing in the stack. Then we start processing the top root node first. So we first process the A node because the process here is root, left, right. So we have to process the root and we here process A. Then the pointer will come at B, but by the time pointer will come at B, the right subtree will go into the stack. The right subtree subnode of A is C. So in the stack we will push C. Now since we are scanning we have processed the root node, now we will process the left subtree. Here again B is the second node. Here again it will be a root node and it has a left tree, but there is no right subtree. So we process B. So process B and then pointer will come at D, but since there was no right subtree, the stack will be having only Phi and C. Now we come to the node D. It is again a root node which has a left subtree and a right subtree. So we process D because we have to process the root. Then the pointer will come at G, but in this case also we again see that there is a right subtree, that is H, and then again K. So we will push the right subtree of this node D on the stack. Here we process G and we put the H, that is the right node of the node D, onto the stack. Now the stack will have Phi, C and H. Now we process G and the stack has Phi, C and H. Now since there is no left and right subtree of G and it is the last node, we start backtracking now, and backtracking involves the process of popping up from the stack. So now at this stage the stack has Phi, C and H, and now we pop the last element in the stack, which is H, and process it. We process H and then we have Phi and C. When we process H, we see that there is no left subtree of H, but there is a right subtree of H, that is K. Since the same process will be followed and we will put K on the stack. Now we have to, since K doesn't have any further subtrees, we will start backtracking. Now while we'll backtrack, we will process K. Here we process K and now the stack will be left with only Phi and C. Now the left part of the tree is processed. Now we have to move towards the right part of the stack, since we can see that only C is left on the stack. Now again we backtrack. When we backtrack, we process C. C is the root here, and again we can see that there is a left node E and a right node F. So after processing C, we have to process the left node E and we have to push F onto the stack since it is a right node. So we process E and we push F onto the stack. After putting F onto the stack, we again backtrack since F doesn't have any further subtrees and E also doesn't have any other subtree. We start backtracking and then we pop F from the stack. Now we have nothing left into the stack. We have only 5. It means that we have traversed the whole tree. Now we have to create a sequence that will represent the pre-order traversal. In a way, we have to write the sequence in which we have processed the nodes. First we have processed A, so we have A here. Then we have processed B, we have B here. Then D, D here. G, G here. H, H here. K, K here. C, C here. E, E here. And then F, F. So this is the pre-order traversal of this tree, that is A, B, D, G, H, K, C, E, F. So first of all, we will process the left subtree, then root and then right. In this example, we have a binary tree where A is the root node and this is the left subtree and this is the right subtree. So first of all, we will scan the left subtree, then the root and then the right subtree. Here again we have 3 lists: process, pointer and stack. Initially we have the pointer at root, that is A, and the stack has null values, that is 5. Now since we have to first process the left subtree, so we will push all the root nodes on the left subtree onto the stack. So here we have A will be pushed onto the stack, then B, then D, then G and then K. Since K is the last node and there is no further child nodes of K, so here we start backtracking. Now when we backtrack, we have to push the top element of the stack, that is K. So first we pop K and K is processed. When K is processed, the pointer comes at G. Now G has no right child, so it will be processed and nothing will be pushed onto the stack. Now after G, we have D on the stack. The pointer is on the D. Now we process D. We process D here, you can see. And then we have to check again whether D has a right subtree or not. Now we can see that there is a right node of D, which is H. So we stop here and then first of all we will have to process this right subtree, which is a root node is H and the left node is L and then right node is M. Now we have to push the root node H and L onto the stack. So we push H and L onto the stack and now there is no child node of L. So we again start backtracking. When we backtrack, we pop the last element of the stack and then we process it. So last element is L and we process L. Then we have these 5 A, B and H left onto the stack. Again we pop the element, last top element of the stack, that is H, and we process H. When we process H, we have to check whether H has a right child node or not. This diagram shows that H has a right subtree, right child node, that is M. So now the pointer will be M and this M will be pushed onto the stack. Now M, again we will check, it has no right child and left child, so we'll start backtracking, and when we'll backtrack, we'll pop the last element, top element of the stack, that is M. Now M will be processed and now we are left with 5 A and B onto the stack. Now we'll again backtrack and pop the element on the stack B. We will process B and then we'll check whether there is a right child of B or not. Here we can see that there is no right child of the node B, so we will pop the next element of the stack, that is A. Now we process A When we process A, again we will check it has a right child or not. Now we can see that A has a right child C. So we have to first process it also and push it onto the stack, and C also has one left child, so we will push both the nodes onto the stack. Now you can see that here we have pushed C and E. Now since E does not have any left or right node, so we'll start backtracking. We will pop the top element, that is E, from the stack and process it. So we process E. Now the top of the stack has C. So we process C. Now while processing C, we will check the right node. There is no right node. So we process C and nothing is pushed onto the stack. Now we have phi onto the stack and there is no node left into the tree. So now we can create our in-order traversal sequence. We can create it from the list of the nodes which we have processed. So first we have processed K, then we have processed G, D, L, H, M, B, A, E and C. So this is the answer of in-order traversal of this binary tree.